welcome learners in today's lesson, and today we're going to look at the central processing unit or the processor. This is another hardware component of our computer, a physical component of our computer. So basically the major function of the processor is to control, monitor and coordinate the working of all other devices of our computer system. For example, a keyboard is a device that falls under input device, and a keyboard cannot transmit data without the intervention of the processor. If you have a device like an output device, like a monitor or a screen, that device is meant to display information, and it cannot display information without the intervention of the processor. So the processor is a key important component which controls the working of the other devices that make up our computer. Now I want to focus on the components that make up the processor. So the processor has three major components. One is a control unit, number two is arithmetic and logic unit or ALU, the number three is registers. So this diagram illustrates the major components of the processor. So when you come across a question telling you or asking you to describe using a diagram, describe the major components that make up a processor or the CPU, basically you have to come up with such a diagram. Then you have to describe the function of each and every component. Now I want to look at the control unit or the CU. So the CU is the brain of our computer, is like the nerve center of a human being for coordination purposes. And the CU performs four major functions. These functions are in form of stages. The CPU, the control unit, operates in form of a cycle, and the cycle has four major stages. And these stages, I was saying, they define the functions of the control unit. So step number one is fetch. Fetch means going into memory, and we are referring to either main memory or permanent memory, and retrieving data, retrieving instructions. For example, you want to add 4 and 2. 4 is data, 2 is what we call data. Now the plus is an example of an instruction. These three components will be loaded in memory. So fetching means going to memory in different locations and retrieving the values of data and instructions from those memories. So basically the CU uses memory addresses, which are unique identifiers to different locations, to access a location and retrieve the content in that given location. So that's what we call fetching. Now decoding refers to the activity of putting an instruction. So this is an example of an instruction, the plus. So an instruction defines an operation. It defines what to do with the data items, how to transform the data items to become information. So these instructions, the manner in which it will be loaded or stored in memory, the hardware that's supposed to add or execute that given instruction will not understand that instruction. So decoding means putting an instruction into a form that can be understood by a given hardware. So the CU tries to put or convert that instruction into a form that the given hardware that is supposed to execute that instruction can understand it. The third function or third stage of the control unit is basically execute. Executing means now the hardware that's supposed to add, we call it the ALU, the arithmetic logic unit in this particular example. So this instruction, the manner in which it will be stored in the memory, the ALU cannot understand the meaning of that given instruction. So we are saying decoding means the control unit puts that given instruction into a form that now the ALU can understand. Now once the ALU understands the meaning of this particular instruction, it will do what we call execute. So the CU has to oversee or control or monitor that given operation. So what we call executing. And executing is an operation of converting data into information by using a particular instruction. In this case, you have what we call the plus instruction. So once it will execute, we come up with number 6. This number 6 is information. So this 6 has to be put back in the storage device for future reference, or let's say now so that it can be displayed on the screen and a user can see. So the fourth function or stage of the CU is storing. Storing means putting back the result of an instruction or an operation into memory for future reference. So we are saying the CU operates in these 4 major stages. Now a combination of these 4 major stages forms what we call a machine cycle. Machine cycle. So the CU can operate several machine cycles, and one machine cycle has these 4 major stages. The first one is fetch, followed by decode, followed by execute, then the last one is store. So the combination of those 4 stages form what we call one machine cycle. So we are saying the CU controls and monitors how other devices functions. I give an example. If you have an input device like a keyboard trying to send data or transmit data into the memory of a computer for manipulation, that keyboard cannot transmit data without the intervention, without being given the go-ahead by the processor via the CU. So the CU uses another device which is now the system clock. The system clock is another device which the CU uses to monitor an operation. For example, if this major operation is given or is supposed to take place within 1 second, so it means that 1 second is an example of a timing, so that another operation can take place in another timing. So the system clock is a device that generates clock pulses, which are basically timings which the CU or control unit uses to monitor an operation. Now we can proceed and look at the arithmetic logic unit. Basically, these are components of the processor that performs 2 major functions. One is arithmetic functions. Arithmetic functions involve mathematical manipulations on data. Things like adding numbers, dividing numbers, multiplying numbers, subtracting numbers are operations under arithmetic operations. The next function of the ALU is basically logical functions. So it performs logic functions or logic operations. Logic operations involves comparing data items so that it can determine whether those 2 or more data items are the same, which one the largest, which one is the smallest. If you have 2 numbers, number 4 and number 2, you want to determine the largest number. That operation is an example of a logical operation. Then lastly, look at registers. Registers are temporal data storage locations which are created within the processor or between the processor and the main memory, so as data can be transformed or manipulated in a particular organized way. So these 2 components always communicate. Processor and main memory always communicate. Main memory, they always communicate. Processor gets data from main memory. Processor returns information from main memory. It gets instruction from main memory. Now it will return information to main memory. So we are saying if I come up with 4 times 2 minus 6 plus 7, it means in such an operation it is very complex. It will use a particular order, not like BODMAS, where a human being can use BODMAS to evaluate this expression. So if we give a computer such an expression, it means we don't want to tamper with 4, 2, 6, 7, those are data. They are steric. Minus, plus is an example of instructions. They have to be loaded in different locations. So there is what you call too much shifting of data. So in this case, it means the processor will create temporal data storage locations to enable it manipulate such an operation. So basically, one is what you call accumulator. Accumulator is an example of a register that enables the ALU and the CU to transform numbers mathematically. So if we have 4 times 2, it means it will create an accumulator for number 4, another accumulator for number 2, another accumulator for number 6, another accumulator for number 7. It will, if it's going to start by taking 4 multiplied by 2, we get 8. That 8 has to be stored in a different accumulator. And the example of register is memory buffer register. Memory buffer register is an example of a register that enables or stores things in form of data and instructions that goes in and out of the main memory. In and out of the main memory. Then we have what to call memory data register. This one stores data and instructions that goes in and out of the processor. Then we have what we call instructions register, IR. Instruction register stores instructions that are supposed to be executed. So that marks the end of our lesson for processor. Let's meet the same time with another topic. Thank you.